Hello, grade 11, this is Tumza 905. So today I've decided to assist you guys with physical sciences. I'm also going to make more uploads for the other grade as well, grade 10 and 12. The reason I'm choosing grade 11 today is because I came across that grade 11 paper. Today's main focus is going to be on mechanics. Specifically, we're going to do vectors in 2 dimensions and Newton's laws of motion. The reason I chose this topic, so what I did is I've taken all the questions that are under vectors in 2 dimensions and Newton's laws. I've taken them from the paper November 2020. So I decided to start with this one first because it's one of the most important topics in physical sciences, and it contributes a lot of marks on paper 1, something like 45%, which is like, I don't know, 60, it's like 68 marks or 60 marks, somewhere there. And overall it contributes like 22% of the marks if we include now paper 2 as well. So if you pass this alone, you're good to go. And next year, good news are, if you master it this year, next year you're gonna like flow like that, because we're just gonna add some touch-ups on it, right? And this was my favorite topic when I was still in high school. I hope you guys are gonna enjoy this lesson. So now let us quickly study the question that is given to us there. Now they say a pulley system is used to keep a crate of mass mkg stationary as shown in the diagram below. So I've drawn the diagram for you guys here, but you can also see it on the screen. I've tried to upload it for you guys there, and I hope it's visible enough. So let us quickly analyze and check what's going on here. So we have the mass, we have the block, and the mass is given to be m. We're obviously going to have to calculate that. It's mkg. And we are also told that the entire system, now this is a system, right? It's not only the block, it's a system. The entire system is at stationary. Now I want us to quickly check what's going on here. Now, the word stationary, it's the key word in that statement right there. Now I want us to quickly analyze it, but before we jump into answering the question and looking at what's going on here, let us quickly jump back to what we did just for revision purposes, right? So let us remember this. For something to be stationary in vectors in 2 dimensions, remember what can happen is you can have a situation where the 2 vectors are applied on an object. Let us take forces, for example, right? So you can have forces like that. Let's call this force 1, and then force 2, and force 2, like that, right? In a situation where you have 2 vectors that are pointing in the same direction, there's one thing that you guys need to remember is that to find f net of this situation here, remember f net, for you to find it, you have to obviously know the definition. You can't find it without fully understanding the definition. Or you can actually, but my advice is also study the definition of f net, because it's one of the most important. They like asking it, especially in grade 11. So f net is that one force that has the same effect as these 2 forces combined, right? And we said is the sum of the 2 forces, right? Now let us, for instance, find f net here. Now the first thing that you need to do whenever you're dealing with the situation of forces like this, you have to choose one side as positive. Now my advice is always choose the side, the direction in which the object is moving as positive. Now if going to the right is positive, if our right is positive right there, now when we substitute the forces on f net, so what we can see is, since f1 is going to the right, f1 is going to be positive, so I'm going to put there positive f1. And f2 is also facing to the right, it's also going to be positive f2. And now the answer to this situation here, if let's say f1 is 5 newtons and f2, let us for example say 6 newtons. Now to find f net here, you're going to say positive 5, we substitute for f1, and you're going to also add the positive 6. That's for f2. Now the answer here is going to be 11. Now the one thing that we can see here is whenever the forces are going the same direction, we always add. If the 2 forces or 2 or more forces, because remember f net can be made up of a lot of forces, or net vector. If 2 or more forces are acting on the object, to find f net, you just find the sum of them. If they're both going to the same direction or all of them are going in one direction, you add. But if you have a situation where one is going in the opposite direction. I don't know if you guys can remember, but here in this situation, what you're gonna say is, you're gonna say, let us say this is our 6 Newton and F2, and this is our 5 Newton, which is F1. In this situation, what you're gonna say is, you're gonna say, if I chose the direction of the motion is positive, in this case, the direction of the bigger force is positive. Now I'm gonna substitute my 6 as positive there, and I'm gonna put my 5 as negative because it's going in the opposite direction compared to the motion that we chose as positive right there. And now the answer here is going to be a Newton. It's going to be 1 Newton. And the direction of that is going to be to the right, obviously. It's going to move in the direction of the bigger force. Now, here we have a different story here. You can also have a situation where the two forces are acting in the opposite direction, but they have the same magnitude. If you have two vectors that are acting in the same direction and they have the same magnitude, what we're going to realize there is, let's quickly prove it mathematically before I say it. Say you have 5 as F1 going that direction and 5 as F2 going in that direction right there. Now to find F net here, you're going to choose any direction as positive, right? Now if I choose to the right as positive, because remember somebody else can choose left, you're still going to get to the same answer though. If I choose my right as positive, then F2 is going to be positive, right? F2 is going to be positive. And then my F1 is going to be negative like that. Now let us substitute. I'm going to have 5 there, plus I'm going to have, for F1 there, I have negative 5. And now the answer is going to be 0. Now what we can conclude here, we have also proven mathematically, it is something that you guys know already, but I was just doing revision for the sake of doing revision. If you have a situation where the forces are balanced and they're going in the opposite direction, then the object is at stationary. We're also going to have a situation like this when we are dealing with Newton's law, especially Newton's first law. This also proves the definition of Newton's first law. I don't know if you guys can still remember the definition of Newton's first law, but it states that an object will move at a constant velocity or stay at rest unless if the forces are not balanced. Now what does that mean? It means when the forces are balanced, there's no going to be movement. If the forces are balanced in the opposite direction, there's no going to movement, or there will be a constant velocity. Remember, constant velocity means there's no acceleration. Acceleration is change in velocity. So when the forces are balanced, this can either move at a constant speed or not move at all. And when that happens, it means F net is 0. Right? We're going to speak about that in the upcoming videos. Now, let us look at the last situation. The last situation that is so important, especially when we are dealing with vectors in 2 dimensions. Now, assume that you have the block and there's a force applied with at a specific angle right there. At a specific angle right there. Whenever you have a situation like this, whenever you have a force that's being applied, or a vector that is applied at a specific angle, with respect to your vertical plane right there, your horizontal plane, I mean. If you have an angle there, this force forms an angle with the horizontal plane like that. In this situation, what you always have to do is you have to break this down into components. So you're going to have, if this is F, you're going to have your Fy component, which is your vertical component, and you're also going to have your Fx component, which is your horizontal component right there. Now, I don't know if you guys can still remember that to find Fy, you're going to use the formula. Fy is going to be the same as F sine theta. Now, the reason why we use the sine there is this comes from trigonometry. If you guys forgot how to do that and you would like me to re-explain it from the beginning again, I will take a video. Please just notify me there on the comments. If there's 10 people if there's 50 people that need help with this, with finding where does the sine come from and where does the cos come from in this case. Where does the cos come from when we are calculating the component Fx? If you need explanation in these two, please comment. If there's more than 50 people that say they don't understand it, I will take a video explaining this, where it comes from. Especially, I will explain trig ratios from the beginning for you guys. So yeah, this is the situation that we have. Now I think we are ready to jump to our question right here. Now, we are told that this system is at rest. Now let's quickly analyze and use what we know to approach this question here. Now my advice is try to understand what is going on before you can jump into questions, or else they're going to show you hell. So please, if you don't want to see hell, analyze. Now what I used to do when I was in high school, I would spend so much time analyzing. And eventually now I can analyze very quick. And what took me to this point where I am today is because I did the analysis of the questions during studies. Now, if you try to analyze during the exams and you've never done it during your preparations, then you're going to waste a lot of time. And I know we don't finish our papers. I'll also give you strategies on how to finish papers and what you need to do in order for you to complete your paper within the 3 hours. And you can also finish it within 2 hours if you follow my advices. For next year, though, when you're in grade 12. And I hope you're going to be willing to put in the work. So what we have here is, let's quickly do some analysis here. We can see that there's point S, we are given point S there, and we have the angle of 30 degrees, and they said to us T2 is 245 newtons. Now, the one thing that we need to take note of is the fact that even though T2 is being pulled downwards by whatever, this could be a person or a machine or a dog or whatever, even though this is pulled downwards like that, the tension that point S is going to experience is going to be in that direction. So I'm going to put that down here. So the tension that point S is going to experience due to T2 I mean, is going to be in that direction. You can see. So it's not going to be, you're not going to draw it like this. No. This is going to experience tension in that direction, even though this is pulled downwards like that. And T1, the tension that S is going to experience is going to be in that direction right there, even though it's been pulled down. And now what we can also see, which is very, very fine to see, and most people might miss it, is the fact that because the block is being held by the string that is attached to the point that we are busy dealing with here, that means this block is also applying tension to point S right there due to its weight. So we can see that we're going to have this. Now, this is going to be T due to this block right here. Now, let me call it T3. That is T3. So point S is also experiencing tension because of the weight of this block. Remember, the block is pulling this point downwards like that, right? And now the weight also, the block, our crate, is also experiencing some forces right there. We can see that the block is attached to the string that is connected to S. Now this S is also pulling up the crate of ours here. That is why the crate is not falling down in the first place, right? And we can, this is the same as, now this force is the same as T3. This is the exact same force. Now the question is, why are they in different directions? It's because of Newton's third law. Now if you go and study the definition, which I will, if you forgot it, I will do a video on that as well. Just notify me there if you forgot about it. But this proves Newton's third law. Object A, when object A applies force on object B will apply the same force but in the opposite direction. We'll speak about that when we are dealing with Newton's laws. And we can also see the block itself also is being pulled down by the weight like that. Now, very interesting, very, very interesting. Yes, because the block, this block M, is not moving up or down, and we are told that it's at stationary. That means the forces that are acting on the block are the same, and they are in opposite directions. So we can conclude here that T3 is exactly the same as the weight of the block, which is the same as, sorry for that. And to find the weight, remember you use the formula mg. Remember, weight is a force that is being applied on the mass of an object. And to find the weight, you're going to say the mass of the object multiplied by the gravitational acceleration, and that is 9.8 right there, right? And it's constant. So this and that are exactly the same. Please keep that in mind. This and that are exactly the same. And this are also the same. We just wrote it down right there. T3 and the weight are exactly the same. Now another last more thing that is going to make our life easier is we can see we have a situation here. And I said whenever there's a force that's being applied at an angle with your horizontal line, you must break that down into the components, right? So let us quickly break this down. T2, let us break it down into its component. We're going to have the horizontal component like that, and we're also going to have the vertical component like that. Now you can draw your free body diagram or your free vector diagram using the components alone, because these two components combined, they make up this. These two combined, they make up this. So I can erase this and only put there my components. That's a beautiful one right there. Components, right? This is your T, Y, and that's your T, X. Now remember, when you're doing a free body diagram, you always have your vectors moving away from your central point right there. So this is what we have. Now we have said that T3 is the same as the weight, right? This is from the block, and this is for S, the letter S. Yes. Now because also the letter S, not the letter S, point S is not moving, it's also at stationary. That means that T3 is also the same as Ty. Now I don't know if you can see something interesting right there. If you say it, you are smart. Please comment if you saw it before I explained it. But yeah, so T3 is the same as the weight, and the very same T3 is the same as the Y component of T2. This is T2 to be specific. This is T2. T3 is the same as T2Y, the component of T2, and the very same T3 is the same as the weight. Now there's a conclusion that we can make about the component Ty and the weight of the block right there. Now we have done our analysis, we have everything that we need, and I think we are ready to tackle down our questions right there. Now 2.1, what they're asking us for, oh sorry, my laptop just went off, you're jealous. So they're asking us to define the term resultant vector. Now please people, especially when it comes to definitions, please, I'm begging you, there's no teacher that can teach you definitions just once and you guys master it from that moment. My advice is definitions, spend time with them. What I used to do when I was in high school is whenever I was struggling with the word, I would write it down 10 times. This was the punishment I was given by my natural sciences teacher when I was in grade 9. And I remember it worked then, and then I started applying it on my grade 11 stages. I'll tell you what happened when I was in grade 10. So please, if you're struggling with definitions, because there's a lot of marks, each and every question basically, I think 90% of the questions that are in the paper, they require definitions. So please go and study those. If it means you should write them 10 times, do write them 10 times. And I'll also do definitions with you guys if you need me to, but I doubt you would need me to do definitions with you. But yes, resultant vector is that one vector that has the same effect as all the other vectors acting in the object, which is the same as your Fnet. Oh, I erased them. But it's the same as the Fnet, just that we replace the word vector with the net force when we are describing them. But it's exact same thing. I'll put the definition here on the screen. Please go and study that. Now let us do my favorite part, the calculation part of this question here. Now 2.2.1. They are saying to us, calculate the vertical and the horizontal component of T2. Now you see the importance of analyzing your question right there. Now we already have the answers to that because we have perfectly analyzed our situation here. Now they are asking for the components that we already have spoken about here. So let us firstly find the vertical component. The vertical component is the one that is going like this, like the way you are standing. I don't know if you are sleeping or not, but like this. The vertical component is this one here, vertical. I know most, especially my learners, the learners that I've taught in the past, they struggle a lot with determining which one is horizontal and which one is vertical. Hey, I just know this is vertical, right? There's no better way to explain it. I will try to find a better way though. So the vertical component is your T2Y. And we said to find the vertical component, we use this formula here. Now here we were using force as our example, but here this is not experiencing force applied, it's experiencing the tension force. So T2y is going to be the same as T2 sine of the angle between your T2 and the horizontal imaginary line right there. Now you can substitute. So you're going to have 2, 4, 5. That's your T2. You just substitute it there. Sine 30 because that's your angle. And the answer that you should get there, please confirm with me using your calculator. You should get, let me see, this is T2y. You should get the, yes, you should get 122.5 newtons. Just please confirm that with me. Yes, please punch that in the calculator and get the answer for us. Now remember, this is a vector. Definition of a vector: it has the magnitude, and a vector is a quantity, is a physical quantity that has a magnitude and a direction. And because we are dealing with the force here, tension is also a vector, so this should have a direction as well. We hardly emphasize on directions, but please keep that in mind because we are dealing with vectors, and all the forces are vectors. So this is going to be 122.5 newtons upwards. We have shown the direction right there. Now let's quickly find the horizontal component right there. We have T2x. Your horizontal component is this one. It's this one. This one here with the gradient 0. Ne? Yes. Yes. It's this one here. Straight like that. That's your horizontal component. To find the horizontal component, we're going to use this formula here. That's your T2 cos theta. And now we substitute. It's going to be 2, 4, 5. 4, 5. 4, 5. Why do we have 4, 5 here? 2, 4, 5 sine 30. And now the cos of 30 degree. And now the answer that we should get there is going to be 212.18. And people, this is not 18, it's 18. After the comma, we don't say 18. It's not a whole number. Those are decimals. We say 18, right? Please, it really distracts my ears when people call it 118 after the commas. So this is what we have for now. Yes, so we have found our horizontal component. We have found the horizontal component of T2 to be 212.18 newtons. And we also have found the vertical component of T2, which is T2y, and that is 122.5. Now, if you forgot what we did, please rewind. If you did not understand, please, I will do a video especially for you and explain what really is going on here if you don't understand, especially with the sine and the cos, where does those come from and stuff like that. So yes, now let's quickly do the next one. They're asking us to find T1. They're asking us to find T1. Now let's quickly check what's going on. Now remember, this point can either go that direction, that direction, that direction, or that direction. It can either move like this, like that, like this. Now the reason why it's not moving up or down is because, like we said, these two forces balance out, right? When an object is at stationary, it does not mean there's no forces acting on it. It means there are forces acting on it, but they cancel out. They're moving in opposite direction. They're exactly the same, but they're moving in opposite direction. So here, the reason why this point is not moving up and down, it means the vertical forces are balanced out. Now, coincidental. This block, it's not only stationary vertically, it's also stationary regardless in any direction that you take. So it's also not moving in this direction. That also means the forces that are acting vertically, the F net of them is going to be 0. And remember, the situation where you can get F net as your 0 under vectors in 2 dimensions is when the forces are exactly equal, but they act in opposite directions. Now, what are those forces that are acting vertical on point S? The forces are T1 itself and T2. Do you see that? Now, we're going to have the F net is going to be 0 horizontally as well. Now, what makes up our F net? Our F net is made up of T2 and the horizontal component of or T1 and the horizontal component of T2. Now, if we choose to the right as positive, this is going to be positive, and if we choose to the left as positive, this is going to be positive, and there's going to be negative. So we can either choose anyone. So let us change now and be like, let us make life difficult for ourselves. Nah? It's unnecessary, but yes. Let us choose to the left as positive. Now, if I chose the left as positive, remember my F net is made up of the sum of these two, right? So my T1 is going to be positive. I don't need to write positive here. Plus my T2, the component of T2, it's going to be negative since I've chosen to the left as positive. So this is what we're going to have here, and this should give you 0. And now what you can do is you can substitute. So I'm going to have T1 positive multiplied by negative is going to be negative, and I'm going to have minus there. Remember, I have the value is going to be T12,18 is equals to 0, right? Now if I make T1 the subject of the formula, I'm going to add to both sides 212,18. Or what we can say is you just transpose this. If you were adding or subtracting this side, when you take it to the other side, you just swap the signs. So since we're subtracting here, when I take it to the next side, when I transpose it, I'm going to get positive right there. So my T1 is going to be positive 212,18. Now this is algebra, people. If you're struggling with algebra again, I will take a video especially for you and explain everything that you need to know under algebra. So now this is positive. Now the reason why it's positive is because we've chosen to the left as positive. So this shows that T1 goes to the left. If we chose this to the right as positive, then we were going to get a negative answer there, and we're going to have to conclude. Right? Now, yes, next, the last one. Yes, now we are being asked to find the mass of the crate. Now, where do we get the mass? This is the formula that gives us the mass, right? This is the formula. Now, we said T3 is exactly the same as the weight, or the mass times the gravitational constant, gravitational acceleration constant right there, right? Now we don't have T3, do we? We don't. We know it's equal to the weight, it equals to the weight, but we don't have the magnitude of it, and we know the direction as well. But luckily, because we have examined our structure, we have analyzed it. Now we said that because this and that are the same, and this is not moving, point S is not moving, point S, this thing S, I don't like it. Point S is not moving, that means T3 and Ty are the same. So we can write that down for ourselves there. But we can say, but we don't have T3, but we know that T3 is the same as T2y. Now this is important because we have the value for T2y. So we can substitute T2y here on T3. So we can say, because these two are the same, now we can substitute T3 by T2y. So we can say T2y is the same as mg, mass times gravity. If this is the same as that, and the very same force is the same as this, that means these two are also the same. And that's what we just concluded here. So now you can say, since we have the value for T2y, we can write there 122,5 newtons is going to be the same as the mass times the gravitational constant, which is 9,8. Now, again, going back to algebra, if we want to make m the subject of the formula, we're going to divide both sides by 9,8 because we want this to cancel out, right? Or you can say we are transposing the 9,8. Now, if the 9,8 is being multiplied this side, if you take it to the other side, you're going to divide it. So multiplication goes to division when you transpose, and vice versa. This is reverse reaction, you see. Positive goes to negative, and vice versa when you are transposing next to the equal sign. This is basic algebraic skills that you need to master when you are dealing with this question. If you don't know how to do them, I'll explain them like grade ones. I don't mind taking the whole video for you. Please don't hesitate to ask me or send me a text, then I will do those for you. So since we are transposing, we can say m is going to be the same as 122,5 divided by 9,8, and the answer that you should get there should be 12.5 kilograms. Yes. Now I used to have a challenge. I used to argue with my kids. So what they would say here is, but Tumza 905, what happened here? The M was on the right side. Now the very same M is on the left side. What's going on? People, it's the same thing. It's the same thing. It's the same thing. This is the same as me saying 2 plus 3 is going to be 5. And 5 is the same as 2 plus 3. Changing the order does not change the fact that those two are the same. There's a better way to explain that. I will do it for you. Now, people, I don't know if there's any of you guys that saw that there's a lot of ways in which we can solve these two. The 2.2.1, the components. There's actually 6 ways in which we can find these values. If you guys know how to find those using the other 4 ways, you are smart. But if you are interested in knowing how to find this using the other 4 ways, then please type down. I will show you how to find those using the other method. Peace. Hope you enjoyed the video. Please like. If I get more than 100 likes within this week, I'm gonna upload videos like this. And also, please, it would mean a lot to me if you guys tell me exactly when you guys are writing. I know the people that are here in Bloemfontein, they're writing, I think next week, but in less than 2 weeks. Wherever you are, just type me the dates of your maths and your physics, and I will upload videos for you every day. If it means I should upload 3 videos just to assist you and make you pass and get 90% or 60%, which is a good pass because we're going to do better in grade 12, I will do that. Thank you so much for participating. I'll see you in the next video.